Okay, here's a quick lesson on how to get information by linearizing data and getting slope from the graph. So this is a problem. We have determined the prettiness of grass outside depends on the window thickness W and the angle theta, which you look out the window. You measure the prettiness at different angles and log them in the table below. And we want to graph prettiness versus angle. So on our y-axis, we put prettiness, and we can put our values. It goes up to about 11, so that works out. On the x-axis, we want angle in theta, which is our degrees, and we can then put our numbers all the way out to 13. Then we want to graph those points and draw in what that graph looks like. And if we try to determine this type of graph, it looks like it might be an inverse graph or maybe a 1 over x graph. We're not really sure. The best way is to try to match up the equations. So let's take a look at that. We're given some fictitious equation where it says that p squared equals w squared times 1 over sine theta. And we match that up with y equals mx plus b. So what we have is that the y value matches up pretty easy with p squared. We have no plus anything, so b is 0, our y-intercept will be 0. The probably most difficult part here is what x is. So we graphed theta. Well, what did somebody do with theta on this equation? They took it and they made it 1 over sine theta. So that's what we want on our x-axis, is this 1 over sine theta. And then our slope, m, should be w squared. So what we need to do is we need to get the values for this. So we're going to do our x-axis is 1 over sine theta, and our vertical or our y-axis is going to be p squared. So then we go through and we get those values. So p squared, and then we just square everything from the p line. So all these p values here, we're going to square those, and we get that. Then we want to get our x numbers, 1 over sine theta, so we can take each of our angles and do 1 over the sine of that and get those values. Then we got to put 1 over sine theta on the x-axis and our p squared on our y-axis. And then we graph those points. We make a line of best fit, and we are going to use the slope, which is rise over run. So we take 2 points that are intersections of where our line crosses spots on the graph, so we can get a nice slope of this. Measure that out. y2 minus y1 over x2 minus x1, 105 minus 20 over 26 minus 6. So we find out that our slope is 85 over 20, or 4.25. But we're looking for what w is. We want to know the window thickness, w. And we remember before that we said that the slope is the window thickness squared, or the window thickness is going to be the square root of m, which is the square root of that 4.25, which is about 2.06. The units for this, just we made stuff up. But if we follow the units, we're going to find that our slope units were p squared, and sine theta has no units, so it's over no units. So our slope was p squared, and then our w was the square root of p squared, so the units would be p, although it's really just made up. So hopefully that helps in the idea to do this and what we need to match up to get a nice straight line graph.